Merhaba arkadaşlar, umarım keyfiniz yerindedir. Geçtiğimiz 2 hafta Almanya'nın Münih şehrindeydim. Burada çok güzel bir atölyeye katıldım. Atölyenin amacı yaşamı nasıl sentezleyebiliriz üzerineydi. Biyofizikçilerin toplandığı, teoretik fizikçilerin toplandığı, aynı zamanda biyolojilerin, kimyacıların, sistem kimyacıların toplandığı bir atölyeydi. Bu geçtiğimiz 2 haftada çok güzel tartışmalar oldu ve sunumlar gerçekleştirildi. Bazı sunumlardan videolar çektim. Bu videonun sonuna ekleyeceğim. O videoları izleyebilirsiniz. Onun dışında da aşağıya açıklamanı koyacağım bu atölyeyle ilgili ve sunumların içeriğiyle ilgili. İlgilenirseniz detaylı inceleyebilirsiniz. Ve bu bilimsel toplulukta çok önemli olan bir atölyeydi. Çünkü yaşam nedir, yaşam için gerekli minimum gereklilikler nedir üzerine hala tartışmalar yüksek derecede devam ediyor. Ortak bir anlayış yakalamak için bu atölyede gerçekleşen tartışmalar çok önemliydi. Ve bunun sonunda da bir perspektif makalesi yazmayı düşünüyoruz. Buradaki düşündüğümüz ve tartıştığımız konular hakkında. Size bir fikir vermesi için bunun sonuna bu konuşmalardan böyle başlangıç olarak eklemeler yapacağım. Daha detaylı incelemek isterseniz bilim insanlarının web sitelerine gidip araştırma okuyabilirsiniz veya makalelerini bulup onları inceleyebilirsiniz. Bir dahaki zamana kadar sağlıcakla kalın.
Do something, but we think of it just whatever is selected, and we need to figure out what are the selection pressures to get the first out of the big sequence space something you want, and for that you need to have inflow. Things need to be continuously fed. Recycling would be great if you can make that happen, and the outflow.
They don't have worse standards than ours, but they look for different things with us. We look for, error bars. They look for, are the cells happy? Do they look happy? And if the error bars are fine, usually the cells do not look happy. And if the error bars are, then the biologist says, this is a good cell. And it gets even worse if you go.
Rhinoceros? A crash of rhinoceros. What about owls? A parliament of owls. A shrewdness of apes. I could go on. Okay. Anyway, so people in the physical chemical sciences, of course, have also been.
That is sort of a mechanism I hope that we can sort of use also if we're starting to think about sort of going from non-living to living systems, but more about that later on. So this is life as you know it, and from a molecular point of view, of course, this is what is really going on in a living system, where each dot is an enzyme and each bar is a chemical reaction, and together
these granules, as they were called, are actually droplets. Observing with the microscope their behaviors, they would fuse, they would flow when they are hydrodynamic. They flow so as to squeeze the tissue. Here you see actually nuclei of the adult worm, and there's wetting of these P granules on the surface.
And then robotic structure, I'll try to convince you. And finally, looking at the RNA replicase and RNA polymerase riboside. Good, outline, already told you little introduction to what DNA, RNA nanotechnology is. This RNA origami methodology.
Why does life need complex lipid to support membrane function and cellular growth and division? And second, how could lipids potentially contribute to the origin or the synthesis of life? How can the emergent properties of lipids be useful in building life? Okay, so just to give a little introduction to what my lab does. In general, we're interested in
Large nucleus, then this is obviously the bottleneck, right? Other questions?
Other one. This is all for nucleated polymerization, but for example, supramolecular polymers field, we have many systems that goes with isodesmic mechanism that actually they don't.
the organizers. So this has been a really super interesting workshop. I've never really had anything like this before, and it's really made me think and consider my own research. So in this talk, I'll talk about cell-free protein synthesis, which we haven't really, it's come up in a number of discussions, but we haven't really had a talk about it yet at this workshop.
As you all know, origins is a very widely researched topic, synthesis much less so. And questions you ask when you want to synthesize life are somewhat different from ours, and I hope my talk will speak to that as well a bit. So, what I'll show you is how various properties of life.
About 2 billion years ago, or plus minus a couple billion, industrialism was already invented by biology, by evolution, on different scales. For example, I will discuss each of these a bit more in detail later, but division of labor.
A much broader question, which is, why is life the way it is? And so this starts from very simple idea. We don't have a definition for life. I don't know if you achieved that in the last 2 weeks.
For me. I'm a liposome biophysicist. I'm biased towards liposomes. So when I talk about synthetic cells, and through all of this talk, when I say synthetic cell, I mean a liposomal bioreactor that makes proteins. So it's a liposomal membrane, so there is a lipid bilayer membrane, phospholipid bilayer membrane. This is not an origin stock. These are very